Hello, everyone. Good morning, good afternoon, and good evening to all. Dear authors and invited guests, welcome to the technical session 9A. I am Anisha Mishra, the moderator of this session. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the 6th World Conference on Smart Trends in Systems, Security, and Sustainability through Zoom. I hope you will enjoy the knowledgeable and interactive sessions through the day. There is a special note for all the presenters. You will be given 12 minutes for your presentation and 3 minutes for question and answers. And on 10 minutes, I'll raise a gentle reminder. There's another request to all the participants that you please stay connected with us till the closing of the session. If you have any update or query, you can write it to me in the chat box. So just before we get started, I would like to introduce you all to the chair of the session, Professor Milesh Kitsing. He is the author of The Political Economy of Digital Ecosystems, Routledge 2021. He is the rector of and professor of political economy at the Estonian Business School. Previously, he worked as head of research at Foresight Center, a think tank at the Estonian Parliament, an advisor at the strategy unit of the Estonian Government Office, and head of economic analysis at the Estonian Ministry of Economic Affairs and Communication. He also served as the president of Estonian Economic Association. His current research interests focus on political economy of digital platform ecosystems. Welcome to the session, sir.
Thank you very much. It's a pleasure to be here.
Thank you, sir. We are pleased to have you here. Okay, so now we'll start with the session. So I'd like to invite our first presenter, Vivek Banerjee, to present his paper title on optimization of resource allocation in cognitive radio network using machine learning algorithm. Dear presenter, you may please start your presentation. I think he's not in the session, so we'll move forward to our next presenter. And the presenter name is Fahdi Saidi Lubis, and the paper title is The Text Mining Analysis Approach for Electronic Information and Transaction (ITE) Implementation Based on Sentiments in the Social Media. Dear presenter, you may please start your presentation.
Okay. Hello everyone, my name is Fahdi Saidi Lubis. I'm from Indonesia. My topic is the text mining analysis approach for electronic information and transaction or ITE based on sentiment on social media. My author is Fahdi Saidi Lubis, Muharman Lubis, Lukmanul Hakim, and Hanif Fahrul Roja. The enactment of legal act in the cyberspace has gained huge perspective of government, organization, business, individual, and other relevant parties around the world. Currently, the establishment of legal act in cyberspace is the inevitable consequence of globalization to ensure the legal certainty of the people who interacting with the internet. With the number of legal infringement in cyberspace increasing each day, the needs of internet regulation has becoming a world concern. Indonesia is one of top-ranking country with high number of internet users, which want to safeguard the public interest with a comprehensive law through UU ITE. The urgency of implementing ITE has been confirmed by numerous cybercrime activities such as spam, copyright infringement, identity theft, piracy, phishing, cyber games of chance, etc. In the following decades, previous law, there are many ICT-based methods could be used by government agency to allow citizens to create political content. The existing and planned policies that post in the website as well as other forms of media related to the government agency are able to allow to citizens to respond immediately. However, the content derived from the political forums, blog, new website, Twitter, and Facebook are the most useful political content. The ITE of Indonesia has been draft since 2020, 3, proposed in 2005 and passed in 2008 with UU ITE number 11/2008 as the cyber law umbrella. Some of related regulation include electronic system and transit operation, consumer protection law, pornography law, and copyright law, and so on. IT address comprehensive content that encompass various relevant cases in cyberspace, particularly e-commerce and cybercrime, while telecommunication law is substitute of law number 3/1989, which regulates specifically of national communication. Basically, telecommunication law is lex generalis of ITE law that do not detail specifically about internet and telecommunication instructive description. In general, Indonesia lags behind terms of cyber law information comparing to Malaysia that had passed a broad set of acts that now considered as Malaysia cyber law, and India, the country which implements a single act that deals with cyber law, namely the Information Technology Act of 2000. The current cyber law that were draft are Information Technology Crime Act, Multimedia Governance Act, and Information Technology Utilization Act. ITE law could not stand alone unless it needs support from other development law. The new development are regulated has to be done by Indonesia legislative because this is the first law governance ICT profession. That limitation, therefore, cannot cover up all issues simultaneously in cyberspace. For instance, the person who commit cyber criminal could also be punished with criminal procedural law codex or other laws. Recently, the first amendment was made together with the government. The parliament approved some revision of ITE law in 27 October 2016 about information and electronic transaction. The Ministry of Information and Technology claimed that there will be no criminalization in term freedom of expression. In early stage, it was pros and cons in the public. With the improvement, the government expect a no multi-interpretation. The law initially used to legalize the ICT usage and embodiment of the governance of telecommunication, media, and informatic laws. The initiative of ITE was drafted by two government agencies. The Ministry of Industry and Trade come out with the bill about the electronic transaction. Meanwhile, the Department of Tourism, Post, and Telecommunication also initiated the similar type of bill on information technology. After some years of bargaining, the government undertook the two initiatives to become the collaborative draft. The table shows the structure of UU ITE. ITE law contains 13 chapters and 55 articles. It does cover comprehensive subject matter such as legality of electronic contract and signature, personal data protection, privacy concern, emperor practice of domain regulation, intellectual property rights, definition of cybercrime and the consumer protection, but others than subject matters that state above will govern by subsidiary regulation. Most the user disagree with an arbitrary power which often persecute the user of internet. Some of them also worried about the freedom of expression on the internet that anytime could conflict them. Famous accounts such as Raditya at Compass.com and Detik.com are often reposted and used by the public to get involved. From this network connection, we can observe which user influence another user to retweet the message and how big the network is. So we can see what are the current issue has discussed in additional for future reference. In case of government agency, they can observe the particular accounts of Twitter to see the trends that evolve among them. The normative issue is one the major concern of Twitter using regarding pasal UU ITE, such a elastic article, defamation of other reputation, consumer protection, and arbitrary power still prevails among internet users in Indonesia. There are many controversial cases assumed against human rights and freedom of expression. This is the list of popular tweets regarding pasal UU ITE. Number one is electric article of UU ITE getting more casual. Please do protect customer right. This tweet is the most retweet with 744 retweets. The use of the mining, the use of text mining can help to identify the perception of specific issue by the following the pattern on Twitter to make accurate prediction about the future trends. Furthermore, to assess adoption readiness factors such as political leadership, international organization, decision-making, and stakeholder engagement, availability of usable science for decision-making, funding for adaptational planning and implementation or evaluation, and public support for adaptation. A text mining analysis has a change to be adapted. It because the source of information of assessing readiness for adaptation relies on speeches of leaders, adaptation planning document, consultant document, grant literature, and opinion polls on perception of climate change, and so on. A certain situation, the research should be considered the relevancy of specific Twitter posts, which requires more manpower analysis them to specific conditions such as sarcasm, metaphor, or any other variant of language attribute. Even though the total number of this kind of posts is not really significant to the overall trend analysis. Since technical measures alone cannot prevent crime, effective crime investigation and prosecute of law enforcement agency is essential to prevent the loss of vital information. Many states and government are currently enforcing strict law and electronic securities. So everyone that is related to the legal soul also be trained in cybersecurity and free from increased cybercrime. To explore the Twitter data, there are many methods can be used, such as multimodal naive bias and many more. Meanwhile, the classification method to perform sentiment analysis enable to classify negative, neutral, and positive opinion. These available tools and methods have big potential to benefit the government agencies in Indonesia to research about social trend in these societies. Besides, the government has to see what the urgent issues are coming from policy implementation, especially ITE implementation that attracted many attention of netizens currently. Some studies reveal that there is a strong correlation between political opinions expressed via Twitter and official poll data, even though it has some drawbacks. Such a poor data with little prediction value because the sample of social media cannot represent the wider public. However, with exponential web generation content available in the social media networking grasp the social science sector, particularly government agencies without doubt can transform public sentiment, response, and ideas to become a new eyes from the government Indonesia. Thank you for attention.
Thanks very much for your presentation.
Okay.
Actually, I have more like a comment on your paper. I think this discussion of cyber regulations and internet regulations that you discussed here in the case of Indonesia, and you made some comparisons some other countries. I think it would be actually helpful to have this placed in a broader literature. There is a lot of literature on internet regulations. I mean here like academic literature. So it would be nice to start maybe some of the main propositions that you get from the literature, and then see how your sort of Indonesian case is fitting in there. Thank you.
Oh, thank you very much.
Okay, thank you for your great presentation. Now we'll move further to our next presenter. So our first presenter, Vivek Banerjee, is in the session now. So we'll start with him. Okay, the paper presenter is Vivek Banerjee, and the paper title is Optimization of Resource Allocation in cognitive radio network using machine learning algorithm. Dear presenter, you may please start your presentation.
Audible?
Hello Vivek, are you ready with
Yes.
your presentation?
Yes, I am in the correct room.
Okay, please go ahead.
Okay. Very good evening to all. Actually, my topic is optimization of resource allocation in cognitive radio network, and that is using machine learning algorithm. So, first I will start with the abstract, what the paper I trained. Regarding to the today, the growing demands of communication network bandwidth for emerging technology, raising the issues of spectrum scarcity, the management and allocation of spectrum in wireless communication are major challenges. So to sort out these problems, we have to work on first the primary sources and the secondary sources. So where we are using the NLP, that is the machine learning programming for network, that is being used for the cognitive radio network cognitive radio network channel, and this technique will help to increase the spectrum use, and where we will use the other tools such as MATLAB and RLA resources.
Sorry to interrupt, but we are not
Yeah.
able to see your presentation. Are you sharing?
Okay. Now is it visible?
No, not yet.
Okay.
And it's not only that. I don't know how is it for others, but I'm actually not able to comprehend anything you're saying because the connection is so bad. So maybe it's better in some other locations, but here I don't understand a single word you're saying. Sorry. Thank you.
Okay, you're not clearly audible to us. Please check your connection. Maybe we can continue later on in the session.
Network issue.
Okay.
Is it visible right now?
No, not yet.
Okay. I'm trying it, but it is visible to me exactly.
No, but you have to share your screen so
Yeah,
that it's
I am
visible to all
sharing
of
it.
us.
I have shared it.
No, but we are not able to see it. No problem. Just check everything once and we'll continue later in the session with your presentation. Okay, for now, we are moving forward to our next paper. And the paper presenter is Saptoshi Bhattacharjee, and the paper title is Performance Evaluation and Analysis of Wi-Fi Security Protocols. Dear presenter, you may please start your presentation.
Okay, are the slides visible to everyone? Can you please confirm?
Yes, it
Anisha?
is. Yes, it is. Please go ahead.
Okay, so hello everyone from my side and Dr. KK Senapathi's side. Good morning, good evening, and good afternoon, based on from where you were joining. So, myself Saptoshi Bhattacharjee, and I am an MTech student from Birla Institute of Technology, Meshra, which is in Ranchi, which is a city in India. And our topic for the presentation is the performance evaluation and analysis of Wi-Fi security protocols. So I'll be guiding you throughout my contents, which starts from the gap analysis in the technology, and then going a little bit with the background of what it is all about and the methodologies that we have implemented. Further, we'll go by the experimentation which we have carried on, and then I will be concluding the presentation. Okay, so on the left-hand side, we see a graph which shows that around 8 billion of devices are connected to the net or to the internet, and a majority of them uses Wi-Fi, which brings us to conclusion that Wi-Fi is a primary means of communication of people over the internet. And over the right hand side, if you see that there's cyber attacks, and due to which the revenues is lost by the company, which keeps on increasing over the years. And this leads to motivation for the study of various Wi-Fi security protocols and to test them further. Okay, so as we have defined the problem, what we have tried to do is to capture the handshake. And handshake generally happens when a new client gets connected to a Wi-Fi network. And from there, we have tried to extract the message integrity code, which is the MIC. And then we have also formed a huge word list. Using that word list, we are trying to regenerate the MIC and then to cross-check that MIC with the captured MIC. And if a match is found, then we can be sure that yes, that is the password which the present network is being used. And the objectives which we have covered over here is that we have studied all the security protocols, both the older ones and the newer ones. We have got hold of the security pins of the older protocols as well as the newer protocols via various cryptographic attacks. And also we have tried to simulate them on a GPU-based machine so as to try and see if we are getting a better efficiency. So a little bit background about the various Wi-Fi security protocols. We knew that it started way back with the wired equivalent privacy, which really had a very small initialization vector, and due to which it gets compromised very easily. It was succeeded by the Wi-Fi protected access and the WPA2. However, the latest version which we have in the market is the WPA3, but which is beyond our scope of discussion. And also it is not widely found across the devices that we are running. So this was a little background, and directly I will jump to the methodology which we have used. We have used a wireless adapter, and which has the facility of monitor mode. In order to have a monitor mode, it is really important to have, because we need to capture the packets that are sent in the air, and hence by capturing the packets, we can carry on with our work. So the first thing is to capture the packets. So we have changed the mode from manage to monitor, and then we check that if the network is web or not. If it turns out to be web, then we again capture a large number of packets. And by just analyzing those packets, we can easily crack the key if it's a web network, which we have also seen is an older network. If it doesn't turn out to be web, if it's a WPA or a WPA2 network, then we first capture the handshake. We create a word list, and then we can crack the password, try cracking the password by using a word list attack. Okay, so moving forward, I would like to say that we have used the Kali Linux as our primary operating system, and we have definitely used a Wi-Fi adapter with the facility of monitor mode. We have used the entire AirCrack NG suite for our work, which also includes AeroDump NG, AirPlay NG, and Crunch for creating the word list. And as for the physical machine, we have Intel's Core i5 10th generation machine with 16 gigs of RAM and an NVIDIA GPU. And as for the VM, for the virtual machine, we have 8 gigs of RAM with Kali Linux installed in it. Okay, so step one, what we have done is that we have changed the mode from manage to monitor of the Wi-Fi adapter. This is primarily required to capture the data that is sent over air. And as you can see, we can capture the data using AeroDump NG command. And then if the network turns out to be web, we can just use the AirCrack NG software suite. And very easily, as shown in the screenshot, we can capture the passkey of the network. Moving on to the WPA or the WPA2 protocol, it is very similar to that, both of them. But here first we need to capture a handshake, which is a challenging task, because the handshake only happens when a new client gets connected to a network. So for that, maybe we have to wait for a whole day if a client doesn't get connected to a network. So for that, what we have done is that we have targeted the client and we have done a deauthentication attack with only 4 packets. So what we have, so by doing that, what happens is that the client gets disconnected to the network for a very small time, and immediately tries to reconnect back to the network. And in order of that process, we get to capture the handshake which we were looking for. And then, as you can see, we have created a word list of more than 111 million words or passkeys by using the tool Crunch. Moving on, this slide definitely shows that after going through all this process, we have used our aircrack ng suite with the handshake that we have captured in the form of .cap file and the word list which we have created. And as you can see, the password is being cracked in around 17 minutes time. Similar based approach we have done by the use of hashcat by using a GPU. As we know, a GPU is designed to perform the repetitive set of tasks in a much more faster way. So we have tried to integrate a GPU-based approach in our thesis work. So in this thing that first we needed to convert the packet capture file .cap into a hashcat compatible format, which you can see .hc22000, this format. And after that, we ran the hashcat format, and the same password, as it can be seen, which was captured earlier with around 17 minutes, can now just be captured under about 6 seconds. So which is a great improvement as compared to what we have done earlier. And then we have also tested the security of a radius server. Till now, whatever we were talking about a PSK or a pre-shared key model, where the thing is that each and every client gets connected to the network via a same password. But in the radius server model, what happens is that each and every client has a different set of login credentials to connect to the network. So we have tried an evil twin attack over here by creating a fake access point in order to test that what is the strength of the radius server based model. Okay, so in this, what we have done is we have created a duplicate access point by using host apt command, and then we have opened the configuration file for the same, and we have changed the SSID name. The SSID name is also, which could be said as the Wi-Fi name, which we see when we connect to a network. The system identifier, which we have changed, and we have kept it to something that people can easily be duped, just like a college network or a company network, such that people will go ahead and connect to the network. And what happens is that when they connect to the network, what gets captured is the username, a challenge, and a response, which is again getting captured in an encrypted format. And hence we use the tool ASC to convert that encrypted format and extract the password. We'll see it on the next screen. Okay, so as you can see, we have supplied ASLEAP, the challenge and the response, which we have captured from earlier. And as you can see, the password over here also could be captured. Although the radius server model is considered to be much secure, but it can also fall prey to some of the other human interactions. Okay, so talking about the timings we have seen using the aircraft model, we had around 7 minutes time, which is drastically reduced by using a GPU-based approach with hashcat with only around 6 seconds. Okay, so this is the comparison chart that we have prepared after studying all the 3 protocols, and WPA2 definitely comes out to be the stronger of all of them. As we know, it is based on advanced encryption standard AES security, which is also one of the most highly rated secure algorithm, encryption algorithm which is used. So WPA2 stands out to be the strongest in all of them. So would like to conclude the presentation by saying that we should definitely only be connecting to the WPA2 network and not its prior 2 versions. And also it is also good to have an ideally long length of password with combination of uppercase, lowercase, special characters and digits, so that because when the length of the password increases, the key domain of the password increases drastically, and the brute forcing of attacks becomes less and less possible for them. And also, if we can try and implement a radius server model for a home network, which is not an enterprise network, then we can achieve a higher level of security in that. The WPA3 seems to be a very modern algorithm, which we need to have more and more implementation and usage. Along with that, a WiMAX feature on or a standard of security could lead us to a better position. And these are the references that I have used in my work. Thank you everyone for your time. Any questions are welcome.
Thank you. Thanks very much. I have actually a question for you. It was actually a great paper and great presentation. Again, thanks so much. A lot of good ideas. Actually, my first question would be that you had this you very briefly had this comparison of the 3 different protocols, and you kind of like ranked them, which is like more secure and which is less secure. Are there any other studies in a similar fashion that you kind of sort of relate to and have come to the same conclusions, or is your study somehow unique in that sense?
Yes, as you can see that in the references, like we have been through some of the studies which they have done, but I think the GPU approach which we have had in our study, which separates us from the others, because we haven't seen a GPU-based approach. Like air crack suit has been there quite long in the industry, and we know it's a benchmarking tool when it comes to passwords. But a GPU-based approach over here, it works as a dream. It works as a magic. Like we spend really long time to find out the hash codes of the GPU of Hashcat, since there were some updates over there. So I think, yeah, the GPU-based approach is something which stands us apart from the other studies.
Okay, thanks so much. And my last question is that you basically discussed, which protocol is more secure and which is less, and so on. But do you also have any ideas how to improve? Even the one that is most secure, the WBA2, still may have some shortcomings, and maybe you have like ideas, or next paper could be about how to improve the protocol, maybe even develop some kind of new protocol. Is that also something that might interest you in the future research?
Yeah, thank you for the question, sir. I agree to your viewpoint. Like what we can do over here is to work on the base algorithm itself, which is the AES, or the Advanced Encryption Standard. As we know, in the form of AES, it works as a base algorithm for the WEP2. And in that form, what we can do is that we can try in form of a triple DES, or maybe an advancement of AES, which can like strengthen the base of the algorithm, since like everything works on how the base of the encryption algorithm is working. So maybe a modification in AES could be a work of future, which can more strengthen the present day WPA2 protocol.
Thank you very much.
Thank you so much.
Thank you for your great presentation.
Thank you, Anisha.
Okay, so now we'll move further to our next paper. The presenter name is Ilham, and the paper title is Developing a Tiny-Oriented Deep Learning Model for an Intelligent Greenhouse Microclimate Control from Multivariate Sense Data. Dear presenter, you may please start your presentation.
Hello.
Yes, Ilham.
Yes. Hello. So I'm Ilham Ihom, and I'm the corresponding author of developing a tiny ML-oriented deep learning model for an intelligent greenhouse microclimate control from multivariate sense data. So we will start this presentation by an introduction. After that, we will see the dataset preparation and model development, then results and discussion. And after that, we will conclude this work by conclusion and recommendations. So crops are highly dependent on climatic factors. Consequently, agriculture is one of the most affected sectors by climate change. In this context, there are two main concerns. The first is to ensure sustainable food production that can feed the world population. The second is the search for new methods to improve traditional agricultural production techniques. Internet of Things, big data, and cloud computing are some of the most promising technologies that may be used to equip the agricultural sector for more effective and sustainable yield production. In this context, we developed a tiny ML-oriented deep learning model for an intelligent greenhouse microclimate control from multivariate sense data. For data collection, we measured 3 climatic parameters: humidity, temperature, and solar radiation during the winter of 2022 inside an agricultural greenhouse, as shown in this figure, located on the terrace of Solar Energy and Environment Laboratory at the Faculty of Sciences in Urbat. The recorded data were collected from indoor installed sensors, cleaned from erroneous records, then labeled according to control actions comprising ventilation, window control, water pumping, or a combination from none up to 3 simultaneous actions. The data set was balanced with respect to each possible action combination, and the corresponding labels underwent one hot encoding. The final deep learning data set was split into sub-data sets. Training cross-validation sub-data set of 80% and the test sub-data set of 20% held out for further evaluation. The data preparation phase yielded a balanced data set of 42,035 records. The control actions combinations resulted in 8 action control strategy summarized in Table 1. To develop our autonomous and intelligent greenhouse control solution, we have chosen a multi-layer perceptron (MLP) architecture that relies on linked artificial neurons arranged within 3 layers types. The input layer, whose role is transferring to the first hidden layer the input variables. The hidden layer, which received the inputs and features and transfers them either to an output layer or an additional hidden one that operates likewise. And the output layer, designed to output the final production. In our study, 2 groups of models have been constructed. The first, with 1 hidden layer, where the number of neurons has been tuned between 1 and 9. The second, with 2 hidden layers, where the number of neurons within each layer has also been tuned likewise. Each model instance was trained and cross-validated on the prepared data. The architecture design phase aimed at finding the model that will score the highest mean accuracy, along with being the least complex. Table 2 and Table 3 show how increasing the layers number and contained neurons generate more parameters. For the case of 2-layer MLPs, the modifications induced in the hidden layer don't operate symmetrically. A tuple of parameters chosen respectively for layers 1 and 2 always generates less parameters than the inverse tuple. For the first model groups, the heat map illustrates respectively the final mean value of the cost, the validation cost, and accuracy and the validation accuracy during the training 5-fold across validation. The model's performance improves with the construction of more complex MLPs. For the first model, the highest score value, this one, for the accuracy and validation accuracy, respectively 94% and 95%, were scored by the model 8. For the second group of models, the highest value for the accuracy and validation accuracy, respectively 94 and 95, were scored by the following models, all these models. So we have 6.9, 7.9, and 8.9, and 9.9. The model with the least architectural complexity is model 8. This model was selected as the final candidate. The first figure depicts its architecture, and the second figure illustrates respectively the evolution of its mean cost and accuracy along the training cross-validation process. A learning plateau is observed starting from epoch 200. The mean loss converged to a value of 0.15, while the mean accuracy, so this one, to 95%. So no gap, no divergence are observed between the training and cross-validation curves, which confirms that the model's learning has been performed within an optimal regime. A further evaluation of Model 8 on the test set yielded an accuracy of 94%. For the test set, this figure shows the obtained classification confusion matrix, where a strong diagonal representation is observed, which confirms anew the model classification robustness. So this work focused on developing a tiny ML-oriented solution for a deep learning-based autonomous greenhouse control based on multivariate sense data. The MLP architecture has been selected in various hyperparameters, have been experimented to train multiple model instances. A robust 5-fold training cross-validation procedure on a balanced dataset was also carried out to find the optimal and the best performant model. From an evaluation metric-based perspective, multiple MLPs can fulfill the task. However, from a tiny ML perspective, only the least complex model has to be kept from optimized computations and minimum inference time. The selected model scored a mean accuracy of 95% and validation sets and 94 on our test set, with a number of 104 trainable parameters. Thanks to its lightness, the model also eliminates the need for using inner regularization technique to prevent overfitting the data. For future work, we recommend unifying model development for the control of multiple corpus types, investigating additional techniques to ameliorate the model's performance and robustness, either from either from a model-centric avenue, which focuses on modifying the parameters and hyperparameters, or a data-centric avenue, which focuses on collecting more refined data. Thank you for listening.
Thank you very much for your great paper and presentation. I have actually a question that, since you're talking about agriculture, greenhouses and so on, and you have this different models, could you highlight some of the practical implications of your research, if possible at all?
First of all, I would like to thank you for your question. I'm the co-author of this paper. So our model has multiple implications, and our approach as well, at the extent that it will enable an autonomous control. So the agriculture people will not be obliged to move to the field and implement manually the control actions. So the control actions will be taken in an autonomous and automatic way without human intervention, which may reduce significantly the costs as well as the human resources that are needed to perform on-field operations.
Thank you very much.
Thank you.
Thank you, Anisha.
Thank you for a great presentation. Okay, so now we'll move forward to our next paper. And I would like to invite Mohammed to present his paper on designing Internet of Things with cooling system sensor for data center in consultation company. Dear presenter, you may please start your presentation.
Okay. Wait a bit. Can you see my screen?
Yes, we can see it.
Okay.
Please go ahead.
Okay. So, good day, everyone. My name is Bambang Hidayanto. It's a pleasure to meet you, and thanks for the time and the Zoom meeting given to us to present our research with the help of developing our society into a better future. The research that we have been done is designing Internet of Things with cooling system sensor for data center in consultation company, which is actually taking place in Indonesia. And I'm also a student in Magister of Informatics System in Telkom University, Indonesia. So there are 5 of us that are doing this research. And for the start, I would like to give you the understanding of what is data center. It is a facility for the computers and its associated components to store or place. So because all the computers and all the associated components is stored in the data center, we will talk about web server, mail server, storage server, network server, etc. that are connected within the same place and operate in 24/7 or non-stop to serve all the needs or activities that are related with the information technology or IT. Like the Zoom meeting that we are doing right now, it is processed in a data center. So by the characteristic and the function that the data center, we can assume that it would be strictly maintained in order to ensure the business activity would run properly without any problem to the customer. So we can conclude that data center plays a very big role for the existence infrastructure of information technology. Moving on to the next slide. What are the problems that are in data center? First, data center costs a lot of energy, with one of factor comes from cooling system. Why is that? Because based from our literature that we have been reviewed, the primary cause of the most serious outage in data center was coming from cooling system incidents, and it's about 20%. And since we are talking about cooling system, there are two parameters. There are temperature, humidity that need to be controlled with a standard. And there is also a problem with the demand for low energy and high efficiency for the power consumption in a data center. Since we all know that around there is a research from the Uptime Institute in 2018 that 40% from the total energy in the data center has been consumed only for the cooling system. So in this slide, we can conclude again, a good function in the center will have the facility of sensing and monitoring temperatures and humidity to reduce unnecessary costs from energy waste. Moving on to the next slide. So what about the consultation company situation that we are placing as a subject in this research? It has the main business in providing data center services. And also, they are performing regular monitoring for the temperature and humidity condition in the server room, physically and manually. By taking into account of the problems in a data center, we state in the previous slide, there should be a system to monitor the environment condition in the server room in ensuring no problems would be happen for this research. So we are proposing something like a system to monitor the temperature and humidity in real time with the Internet of Things as the approach, with the hope of operator can monitor the server room temperature and humidity from the application. Moving on to the next slide. There should be a question, what is Internet of Things that we have been discussed in this research? By looking at the figure, it is a concept in aiming the expansion of the benefits from continuously connected internet connectivity. As an emerging topic, the IoT has become prominent as solution for the connection of device into internet connection to deliver desired function. As you can see, IoT has reached every sector, which in this case is delivering the temperature, humidity data from the sensory devices through specific network protocols and interconnection to specific cloud platform service that is set. So we are planning in having several components, especially sensory devices that can read temperature, humidity, then send the captured values through the wireless connection to be monitored through application on the smartphone. The sensor would be attached to a microcontroller that can be assembled with the combination of Arduino for the microcontroller and also the DHT11 for the sensor of the temperature and humidity, and wireless module ESP8266 to send the captured data to the application. So this is the research methodology that we have been used in conducting this research. We are using PPDIOO lifecycle approach that is developed from Cisco. And it has 6 stages, including prepare, plan, design, implement, operate, and optimize. But in the study, we are doing only 3 phases, prepare, plan, and design. For the implementation, we change it into interpretation. So we can test the prototype that we have been designed and analyze the result to make it as a research. So looking at the figure, you can see we are trying to identify the problem, which already been stated in the first slide. And also we are trying to figure out what has been researched in the past from the literature study. And we are classify the research that we have been doing. And we also doing the observation and interview with the consultation company for the server room condition and identifying the required components to create the prototype. And after that, we are designing the prototype and test the prototype. And after that, we analyze the result and we will find the conclusion about the design of the prototype that we have created. Moving on to the next slide. This is the implementation that we have been done. This is the module that we have been installed in the Arduino Uno. It is a wireless module to capture the data and send it to the application. And this is the sensory devices, the HT11, that we install also in the Arduino Uno, in hope that we can attach this microcontroller with the sensory device in the server room to check the temperature and the humidity. So for the next implementation, we are doing the programming using the Blink application. We declare the library of the module that are installed into the microcontroller, and later on defining the function to be used in reading and capture the temperature and humidity values from the sensory device, the HT11, with the given interval. So you can see we are trying to create the programs, and then we will install this program into our smartphone. So the objective of this research is the operator will have the capability in monitoring the server room using the device that we have installed in the server room. So this is the result. Actually, there are two scenarios, and according to ANSI/TIA 942, the consultation company has standard for the operating temperature and humidity in the server room around 20 to 20 degrees Celsius, and the humidity between 40 to 50%. So this is the first scenario which we situated the condition of the server room. We try to set the cooling system in the server room to be functioning or on, and then we capture the data between 5 intervals from start to 15, 30, 60, and then 180 minutes. This is the screenshot from our applications. As you can see, the picture from the left is the condition, as the first condition from the application, from the server room, I mean, and it has like 23 degrees Celsius. And the picture from the right, the temperature get lowered down into 21 degrees Celsius. So we can capture the temperature and also the humidity with the fluctuative or dynamic graphic. And then for the second scenario, we situated the condition in the server room with the cooling system is off, and then we capture the same with the same interval from start 15 minutes, 30 minutes, 60 minutes, and then 180 minutes. We can see that the application is also showing the dynamic change from the temperature and humidity that is being read by the sensory attach. Looking at the trend, the temperature is increasing from 27 degrees Celsius into 30 degrees Celsius, and the humidity from 79% to 77%. Moving on to the next slide. This is the comparison from the temperatures and also humidity. You can see with the condition of the cooling system is on, the temperature got decreased, and the application can read the change from the temperatures. And also when the cooling system is off, the application can also read the dynamic change of the temperatures from 22 to 30 degrees Celsius. And it's same to with the humidity. You can see the blue marks, it's the second scenario, and the green marks is the first scenarios. So after we test the prototype, of the cooling system sensor, we get the conclusion. First is the design and the development of cooling system sensor based on IoT. Following it with the approach of PPD-IIO lifecycle approach can be further research in assisting the mechanical function to address the temperature and humidity change. And it is expected to extend the capability from the device in managing the data storage with the proposed idea of having a monitoring system that can process and enable the features of controlling the energy consumption without excessive use. So this is maybe the first project for us, the first research for us. It only has monitoring capability, but later on we maybe get a chance to research further to have the controlling capabilities. Thank you for the time and also for your attention. If you have any question, please feel free to ask.
Yeah, thank you. Thank you so much for your presentation and the paper. I have a couple of questions, actually a little bit like going beyond what you're doing. I mean, my first question is that what is you're talking about energy efficiency within the data center, but what's the source of energy? Where does it come from? What kind of energy is energy provision stable? Then can if it's not stable, there are blackouts or something, can that also have effect on the data center? And are there alternative choices made about energy provision? I mean, are there alternative sources of energy that we can choose between? So those are my questions. Thank you.
Okay, thank you for your question, Mr. Mills. So looking at the situation from the custom packaging company, that is actually the subject of our research. It's only using maybe it's only assumption, but maybe they are using the fuel energy that fossil energy that have been generated by our government. So it is like something that we cannot change about the policy, about the source of the power. So instead, we are trying to, control and also monitor. What we trying to do is we want to emphasize about the capabilities from the data center, from the operators. That is the first objective. So they don't need to, stay in the data center all the time. They can like monitor from outside the office and also control it from their home, maybe, just like that. And I forgot about the second question. Can you repeat?
Basically, I asked whether is the provision of energy stable? Are there blackouts or no? That's not an issue.
We didn't have any collection of that kind of issues when we are doing this research. So I'm sorry, but I cannot answer your question.
Thank you. Thanks very much.
Yeah, you're welcome. Thank you.
Okay, thank you for your great presentation.
Yeah, you're welcome.
Now we'll move further to our next paper. And I would like to invite Nuruddin El Sheikh to present his paper on System for Monitoring and Managing Electric Vehicles Charging Using IoT. Dear presenter, you may please start your presentation.
Hello, can you hear me?
Yes, we can hear you.
Okay, just a moment, I'll share screen. Good afternoon, my name is Nuruddin, and I'm a computer engineering student at Qatar University. In this presentation, we have a system we designed to hopefully ease the transition to electrical vehicles, as many countries have already set a goal to replace the conventional fuel-powered cars to electrical vehicles. Before we go into details, we have the table of content here. We have 4 main sections, followed by a small animated pitching video, which will help illustrate the system idea further. So first, before going into our proposed system, our motive behind this project is due to the increasing concerns over environmental issues. We want to contribute to the considerable effort that is put into the development of sustainable energy. So with that being said, our system consists of 3 main modules: the electrical vehicle module, which represents the owner's vehicle itself, a charging station module, which is to simulate the entire station, and a charging point, which is the charging node at the station. These diagrams in front of you show the hardware and software we used. Most importantly, the Raspberry Pi 3 and the what do you call the Firebase. These two were very crucial in developing our system. So how did we design each module? First of all, we started with the electrical vehicle module, which is basically we have a microcontroller installed in the user's car. We want it to be modular and to support any electrical vehicle out there without constraints. So we used an current voltage and temperature sensor to read the battery. And then using a machine learning model, we estimated the percentage battery. We will go into the implementation later. Also, this microcontroller is capable of connecting wirelessly to other devices. Again, this will be illustrated and shown why did we use this in another slide. Next up, we have the charging station module. This contains two main systems. First, we have an MQTT server to help facilitate the communication between the user and the station. And then we have a detection model used to count the number of vehicles in the station, which will be used as well in the estimation later on when the user wants to reserve a time slot for charging. And the last module we have is the charging point module. This one is used to facilitate the charging process by reading the state of charge value given from the electrical vehicle battery, and then handling the mechanism using a relay. So after the user scans his ticket, which is the captured image in the diagram, if it's verified, the charging point will allow the charging until it reaches the user's desired charge level. Now, to go into the implementation, the electrical vehicle module, we have the voltage current sensor attached to the electrical vehicle battery to measure the voltage and current. And then we have a temperature sensor. The models are given, by the way, on the slides, to read the ambient temperature around the battery. These three inputs are required to for the model, for the machine learning model. This will be shown again in the slides later on. The machine learning model was trained to help in accurately estimating the battery charge using the artificial neural networks, and the details will be shown next. Next up, we have the charging station module, which is again using a Raspberry Pi 3. This one we installed on it an MQTT server, and we used the YOLO V5 detection on it. This way, it was accurately able to count the number of vehicles in the station at any given point. The Raspberry Pi also proved powerful enough to handle those two tasks. The server, the Raspberry Pi also stores the reservation tickets, and after the user is done charging, or if he cancels the reservation, the ticket is then deleted. And the charging point, which represents any charging node in the station, it has a Raspberry Pi 3 again with a channel with a relay. This relay is used to control the discharging and charging of the battery. The smart way of making the charging point itself handle the process. And then a camera that's plugged into Raspberry Pi, which is used to scan the ticket. The ticket is a QR ticket generated on the mobile application, which we have here, the mobile application. It has, the mobile application has numerous screens, but the main ones we have mentioned here are the dashboard screen and the reservation screen. The dashboard screen contains information about the vehicle itself, like how much charge is left in the car and etc. And the reservation screen is the most important part of the program because it allows the user to choose the appropriate station without having to search for it manually. It has an assistive reservation feature. The screenshots for these will be shown in the evaluation part. We also have the machine learning. We used a multi-layer perceptron protocol for topology for this. And again, we fed the voltage, current, and ambient temperature for it. We used roughly 17,000 samples, and we tried training it for an hour, which was able to produce 99.7%, roughly 99.7% accuracy. We conducted testing because the project has different modules, so we had testing at every module. But for now, we only included the main parts of the results we've got, the tests that we conducted on the test system as a whole. So starting off with the charging estimation, we were able to accurately use the state of charge model we trained with an accuracy for testing of 99.6 as well. And as we mentioned before, 99.7 for the training. The mobile application, these are some screenshots from the application. We couldn't include all of them due to the constraints. But for first testing we wanted to check that the user was able to reserve a time slot that's actually valid. So as you can see in the first image, anything that's marked as red, that means it's either has been reserved or it's past due, so you can't reserve it for the day. And the green ones are the ones available. We also tested the Bluetooth connection. This is another thing we implemented in our project so that the user can connect his mobile application to the vehicle. And with that, the user can receive the percentage of the vehicle at any given point. So he can track the charge of the vehicle, and the mobile application can notify the user if the battery is dropping at a certain threshold. The user can also define which value does he want to be warned at. For example, if he wants to be warned at 50% when the vehicle is below 50%, he can do that. If the vehicle loses connection with the car, with the mobile application, the mobile application is capable of detecting so and notifying the user. For the reservation part, the user can reserve, and it shows him, as you can see in the first screenshot, confirmation screen showing the estimated price and if there is any vehicle right now in the station. And after the user successfully reserves, it generates a QR ticket, which then has to be scanned at the station for the charging to start. For the next few minutes, we're gonna play a small video. Please let me know if the audio isn't working or if there's any issue with it.
Bored of waiting in long lines? Or maybe from searching for a charging station on the last second? Yes, electrical vehicles' battery is just unpredictable. It changes in an instant. And with the uncertainty it holds, it's hard to make decisions. For that reason, it would be nice if there is a system that can take all that into consideration to monitor and manage each charge. And for that, we present a system for monitoring and managing electric vehicles charging using Internet of Things technology. The system consists of three main modules: the electric vehicle module, the charging station module, and the charging board module. In the electric vehicle module, the electric vehicle battery is monitored for voltage, current, and ambient temperature. These data are then used with the machine learning algorithm to get the state of charge value. After that, state of charge values are sent to the connected device's request through the Bluetooth connection. In the charging station module, there are three main parts: the safety system, the detection system, and the management unit. The management unit is responsible for establishing a data exchange connection using the publish-subscribe approach. This is important for topics such as safety, reservation tickets, and the number of electric vehicles in the station. Now, with the detection system. Here, the system monitors the number of electric vehicles using the YOLO algorithm, and then feeds this number to the management unit in the related topic. In the charging board module, the system has 5 relations that work in order: the QR code detection, the ticket validation, the Bluetooth connection, the charging, and the ticket deletion. In the detection, the system keeps processing the camera output until it sees the QR code ticket. Then, the ticket is checked to make sure that it's valid. The connection is established via Bluetooth. The charging point requests the state of charge from the electric vehicle, and when the state of charge reaches the desired value, the charging is stopped. Now, the ticket deletion is done if the charging was completed successfully. Now, the last important piece of the puzzle, the mobile application. From the login screen to the state of charge monitoring, the mobile application is just unique. But there are two things that make it even more special, which are the warning system and the assisted reservation. The warning system monitors the coming state of charge values on the electrical vehicle. And when it notes a critical value coming, it warns the user immediately. For the assistive reservation, 3 preferences are given to the user to choose: the shortest distance, the least waiting time, and the lowest total cost. Of course, these preferences can differ from one user to the other, and they are available anytime, all the time. Electrical vehicles charging is simply different. It comes with many challenges, especially for people that have never seen or used electrical vehicles before. However, this is what electrical vehicles need: a push that can facilitate their evolution in the region. And who knows, maybe this one can make the difference. Board of waiting.
Okay, and that brings us to the end of the presentation. Thank you everyone for listening. If you have any questions, you're welcome to ask.
Thank you. Thank you very much. And thanks for the presentation and the paper. Just the 2 really quick questions because we are kind of running out of time here, I guess. First, did you carry out any kind of a risk assessment for your system? What are some of the main risks associated with it? And my second question is that did you make any comparisons with other systems or countries, and what makes your proposed system unique? Thank you.
Okay, thank you for your questions. For the risk assessments, we did look into the current market and the environment around us to make sure we don't have any competitors at the moment. The only main competitors out there are Tesla and the proprietary cars. Like some cars offer their own system, but no one has a modular system for all of the cars. And for the second question, can you repeat it again? I'm sorry.
Comparison with any other countries or any other systems that are out there, and what makes your system unique. I already understood it from your question, so your answer that it's unique because it's supposedly accessible to all cars.
Oh, yes.
Is there anything else?
It mainly has modularity and it's customizable. The user can define whatever he wants from the mobile application without being constrained to specific systems or like default apps. Some apps maybe show you the closest station. Some apps maybe will show you the lowest price. This one provides to the user customizability. He can add in any number of vehicles he wants to the same account. He can monitor all of them, and he can choose best station suiting his needs without having to be constrained to the specific system.
So basically it's sort of kind of like the technology neutrality and avoiding vendor lock-in somehow.
Yes. It's giving the customer the freedom. We want any customer to be able to install it as well. That's why we included a separate modular part for the measuring battery instead of relying on the already built-in and each vehicle ones.
All right, excellent. Thanks so much.
Thank you.
Thank you for your great presentation. Okay, so now we have Vivek Banerjee again to present his paper. Let me just see. Vivek, are you here? I think he's having some network issues. Okay, so we'll move further. All the papers have ended now. I sincerely thank all the presenters for their excellent presentation and contribution in this session, and all the participants for being a part of this international conference. I hope the session was informative enough. We, on behalf of the whole team, thank you for your support during this version and the previous 5th version of the conference. I hope to see you in the next 7th version in 2023. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the paper have already forwarded to Springer. The publication will be live within 6 months. Kindly cooperate with the team of WS4. I also like to thank our session chair for chairing the session. Here is a token of appreciation on behalf of the team of WS4 and Global Knowledge Research Foundation. Thank you for your valuable presence, sir.
Thank you very much. And it was a pleasure to be here. And thanks for everybody for the presentation. So I learned a lot, and good luck to you.
Yes, thank you. Okay, so as we have come to the end of the session, I would request you all to please switch on your cameras for a quick snapshot of this virtual conference. Okay, thank you so much. Stay safe and take care.